In this video, you will learn how the vapor pressure of a compound is related to exposure potential. Earlier in the course, vapor pressure was defined as the pressure that a vapor exerts on a closed container at equilibrium with its condensed phase. Higher vapor pressures are indicative of higher evaporation rates. The figure on the screen is a vapor pressure curve. It's used to illustrate the relationship between temperature and vapor pressure. As you can see, there are 4 compounds with 4 different curves. Two important things to note about this figure. First, the vapor pressure increases with increasing temperature. Second, the temperature at which a liquid boils is the temperature at which the vapor pressure reaches atmospheric pressure. This can be seen at the 760 torr mark, where each curve crosses that 760 torr marking. Let's focus our attention on diethyl ether in red and ethylene glycol in green. You'll note that diethyl ether has a very steep curve, meaning its vapor pressure rapidly increases with very small increments in temperature. Whereas if we were to look at the ethylene glycol curve, we would see that it hardly changes very much with increasing temperature. If one were to compare their occupational exposure limits for diethyl ether and ethylene glycol, they would find that diethyl ether has a short-term exposure limit of 500 ppm, and ethylene glycol has a short-term exposure limit of 39.4 ppm. This means that it takes significantly less ethylene glycol to cause harm than diethyl ether. If we were to base our exposure controls only on this information, one would likely make the decision to control inhalation exposures from ethylene glycol over those of diethyl ether. However, if we were also to consider the vapor pressure of each compound, we would see that at 20 degrees C, a typical working temperature, the vapor pressure of diethyl ether is significantly higher than that of ethylene glycol. This means that if we were to have equal volumes of diethyl ether and ethylene glycol in 2 separate and similar containers, there would be significantly more vapor of diethyl ether in the air than that of ethylene glycol. Therefore, exposure potential is also higher for diethyl ether over ethylene glycol. The implication is that even though diethyl ether is significantly less toxic than ethylene glycol, one should have ventilation control when working with diethyl ether, whereas no ventilation would be required when working with ethylene glycol. Understanding the exposure potential of each compound helps us understand which compound is actually more likely to cause us harm, and therefore which compound requires more control. So that is a summary of how you can use vapor pressure to help you understand your inhalation exposure potential from a compound.